Let's take a look at how to find the constant of variation with tables. This table shows how the total number of doodles Addison draws depends on the number of hours she spends in class. How many doodles does Addison draw during an hour of class? Okay, so when you have a table, remember you always have the X column on the left and the Y column on the right. So these are the time in class is our X hours and the number of doodles is our Y variable. When you're finding the constant of variation, it's one of the Y values divided by the X value that goes with it. Now the nice thing about this is since we're assuming it's a constant rate, we should get the same answer whether we use the 0.510 or whether we use the 0.714. Okay, so let's say we use the first point. Let's say we look at 510 first. Okay, well if we set it up as y over x, well our y value is 10 divided by our x value, which is 5. And 10 divided by 5 is 2. Right, so that would tell us if she's making 10 doodles in 5 hours, that she's making 2 doodles per hour. Or every hour, she's making 2 doodles. Now, notice it shouldn't matter if I picked the other point. If I wanted to use the 0.714, I would say, okay, well the y value is 14 divided by the x value of 7. And notice it gives me the exact same answer. 14 divided by 7 is also 2. And this should always be the case if you have a constant rate. So every hour of class, she draws 2 doodles. The table below shows the relationship between students and how many teachers are required to teach. How many students does it take to require an additional teacher? Okay, well remember we said this is our X column and this is our Y column. So if I want to figure out the students per teacher, right, how many students to require an additional teacher, I would take the Y value divided by the X value for either point. So let's say I took the first point, 2, 4. Well, that would be 4 students for 2 teachers. 4 divided by 2 mean there's 2 students per teacher. Or for every 2 students, we would need an additional teacher. And again, notice we would get the same answer if I used the 0.48, because 8 divided by 4 would also give me 2. Using the table below, find how many more additional passengers can be taken on the train by adding a single train car. Okay, well our train cars are X and our number of passengers are Y. So I can see there's 4 passengers in 2 train cars. So 4 divided by 2 shows me that I have 2 additional passengers for every additional train car, or 2 passengers per train car. I would get the same thing if I had used my other point, right? 12 divided by 6 would also give me 2. Alexander is making his own apple juice from the apple tree in the backyard. Using the table below, find out how many bottles he can make in each day. Okay, well we can see in 2 days he made 6 bottles, and in 3 days he made 9. Okay, so it looks like it's moving at a constant rate. So we can say the bottles of juice, or Y, divided by the number of days, or X, will tell us how many bottles he can make each day, or bottles per day. And again, you can choose to use either point. Let's say I use the 0.26. I would say, okay, 6 bottles divided by 2 days means that he makes 3 liters per day. The table below shows how the number of cats you own depends on how many rooms you have in your house. How many cats can you get for each additional room? Okay, well for 9 rooms we have 9 cats, and for 13 rooms we have 13 cats. So if we divide this out, right, 9 divided by 9, or if we chose to do 13 divided by 13, we get the same thing, we get 1. So notice the number of rooms and the number of cats are the same, right? 9 and 9 or 13 and 13. So for each room, you get one more cat. The table below shows the number of cats you own depend on how many rooms in your house. How many cats can you get for each additional room? Well, notice it's the same, right? 5 rooms, you get 5 cats, and for 12 rooms, you can have 12 cats. So if we divide it out, right, 5 divided by 5, we have 1, which makes sense. For every room, you get 1 more cat.